In this video lecture, I will explain relationship between finite automata and regular expression. So here we will show the relationship between DFA, NFA, null NFA and regular expression and how to obtain null NFA from the regular expression. So once we have a null NFA, we can easily construct a DFA, and we know that any language accepted by a DFA is a regular language. Okay, and if DFA is obtained, we know how to obtain a DFA from null NFA, and same way a DFA can be obtained from NFA also. So we can say that any language accepted by null NFA or NFA is also a regular language. Since a null NFA is obtained from a regular expression, we can say that a regular language in fact can be denoted by a regular expression. So given a regular expression, we can obtain null NFA. From null NFA, we have already seen how to obtain DFA, and also from null NFA how to obtain NFA. So either we can construct NFA from null NFA and then DFA, or null NFA to direct DFA conversion is also possible. Okay, so regular expression, null NFA, NFA and DFA all represent the same, and same thing means they all represent the regular language, but the notations are different. So this diagram represents the relationship between regular expression, null NFA, NFA and DFA. Okay, so we can directly write null NFA from regular expression, or we can construct a DFA also from a regular expression. So now next we will see how to obtain a null NFA from a regular expression. So there is a procedure to write null NFA from a regular expression. If you want to directly write a DFA from regular expression, then the way we construct a DFA, same way we will be constructing a DFA here also. So whatever regular expression is given to us, we will be writing all the valid string for that regular expression, and then how we construct finite automata, I mean a DFA, the same way we construct the DFA. But a regular expression to null NFA, there is a procedure. Now, how we write a null NFA from a regular expression? So regular expression, there will be some regular expression, okay, and that regular expression will be for some language, and then this is the finite automata. So here this finite automata is nothing but null NFA. Okay, so now we know phi is what? Phi is a regular expression for empty language, or empty language we can represent by opening and closing curly braces. So now we are saying the language is empty, that means nothing is accepted by a finite automata. So we know that for any finite automata there will be some start state and some final state. So Q0 is start state here, QF is the final state, but there is no transition from start to final, so it is not accepting any language. So phi, if a regular expression is phi, this will be the null NFA for that. And then if I have epsilon, so epsilon is a string of length 0, and this is the language, or we say that regular set. So this regular set is nothing but we are saying the language. So here epsilon is the language. So now if string of length 0 should be accepted, what we should do? The start state should only be the final state. So here Q0 is start as well as final state. So remember, always whenever we have to show the acceptance of the null string, we need to make start state as a final also. And then if there is some input A, okay, that belongs to the symbol sigma, so only one input is there, only one string is there. Okay, so this means only this language has only one string A. So only if the string, so this is what? String of length 1. To show the acceptance of string of length 1, we should have two states. So there is one start state and one final state, and we start from Q0. This to start with, the machine will be in state Q0, and if I give input A, it is accepted. So this is the null NFA for single input. Now, if we know that if R1 is regular expression, R2 is a regular expression. R1 plus R2 will also be a regular expression, because we have already seen union, concatenation and star. These are the operators allowed. When we write the regular expression, these three operators are allowed. So when R1 is a regular expression, R2 is also a regular expression. R1 plus R2 will also be a regular expression, and this will be the regular set for that. Now we have to construct a null NFA for that. So that means either R1 should be accepted or R2 should be accepted. That is the meaning of union. So this is union operation. Plus is nothing but union operation. Concatenation means both should be should be accepted. So here if I say R1 plus R2, either R1 should be accepted or R2 should be accepted. So we start with Q0. Null means no input, and then R1 again no input. So that means R1, if I choose this path, R1 is accepted. If I choose this path, if I take from Q0, if I come to Q1 from Q0, R1 will be accepted. If I choose this path, then Q0 to Q2, if I come, null, and then R2 and null. So that means R2 will be accepted. So if I say null, R2, null, so that means R2 only. Here if I say null, R1 dot null, so this means R1 only. So if I choose this path, R1 will be accepted. If I choose this path, R2 will be accepted. So this is how we write a null NFA for R1 plus R2. Now in place of R1 and R2, I can have A plus B. So if I have to, if my regular expression is A plus B, I have to construct null NFA. So what I will be doing, instead of R1, I will be writing A. Instead of R2, I will be writing B. And then the next one is R1 dot R2. If R1 is a regular expression, R2 is a regular expression, R1 dot R2. So concatenation means R1 and R2 both should be accepted. So this is a regular expression for R1. R1 dot R2 is also a regular expression, and this is the regular set. Now R1, here in R1 plus R2, either R1 should be accepted or R2 should be accepted. So there will be two paths from the start state. But in R1 dot R2, there will be one path only, because both should be accepted at the same time. So R1, then R2, and then null. So R1 dot R2 dot null is nothing but R1 R2 only. So there will be one start state, and this QF is the final state, and these are the intermediate states. So if suppose I have to show if my regular expression is A dot B, so then I can write here in place of R1, I will write A. Here in place of R2, I will write B, and then null. Or what you can do, in between R1 and R2, one more null transition you can show. So you can show something like this: Q0, and then R1, and then again null, and then R2, and then again null, and final state. So you can show like this also: Q0, Q1, Q2, Q3, and this is final state. So like this also you can show, or in between this null you can skip. Okay. Next is R1 star. So what is R1 star? It is clean closure. So we know that if R1 is a regular expression, R1 star will also be a regular expression. So R1 star means any number of R1. So if I say, for example, if I say I have to show the I have to write a null NFA for A star. So what is the meaning of A star? When we put 0 here, it is epsilon. When we put 1 here, it is 1A. When we put 2 here for star, it will be 2A's. When we put 3, it will be 3A's, and so on. So any number of A should be shown. So epsilon should also be shown. So when we say epsilon is shown, so there is one Q0 and QF, and directly from Q0 we are showing the transition for null. Okay, and Q0 is the start state. So you can see here null is accepted, and then R1, and then R, and then what we are doing, again null transition. Okay, so here if I say this one, that means null is accepted. Then null R, null, that means 1 R is accepted. Then null R, null R means 2R is accepted. Then null R, null R, null R, null R means 3R is accepted. So this null move, null transition, why we have shown? Just to repeat this R any number of time. Okay, so this is how we can construct a regular expression for A star. So in place of R, you can write A. So what will happen when null means this Q0 to Q of this transition you have to take. When single A means null, A, null means one A only. Then 2A means null, A, null, A, null. So 2A is accepted. 3A means null, A, null, A, null, A, null, A, null. So like that you can show any number of A is accepted by the machine. So this is the null NFA for A star. Now let's take one example. If I have to construct a regular, if I have a regular expression A plus B star, I have to construct a null NFA for that. So A plus B, we know how to construct A plus B. So there will be two paths, either A or B. So this part is A plus B. Okay, so from Q1 there will be two paths, one for A, there will be one more path for B. So if I choose this path, A will be accepted. If I choose this path, B will be accepted. And we know that how to make null NFA for A star. So there will be one more null transition here, one after this, and then this one is to repeat number of A or number of B. And to show the acceptance, because it is star here, so null string is also accepted. So to show the acceptance of null string, there will be one transition from start to final for null move. Okay, so see here, null is accepted from Q0 to Q7. If I say only A, so we'll take this path, null, null, A, null, null. So if I means before A, if I say null, null, A, null, null, any number of null, it will be A only. Okay, now if I say only B, means null, null, B, null, null, B is accepted. If I say, so see, A plus B star, we have already seen in my previous video that what is the meaning of A plus B star. Any combination of A and B means string of any length that is made up of alphabet A and B. So epsilon, string made up of only A, string made up of only B, or string made up of A and B. So if I say any number of A, so null, A, null, 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 A, null, null. So any number of A will be accepted. Same way, if I say for B, so you can see null, B, null, then null, null, B, null, null. So any number of B or any combination of A and B. If I say null, A, null, 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 B, null, null means A and B is accepted. If I want BA, so we'll choose this path first, null, B, null, 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 A, null, null. So like that, any combination of A and B is also accepted. So this will be the null NFA for A plus B star. So now if I say A dot A plus B star dot BB, so what we have to do? This null NFA, before this one more transition for A we will take, and here two more state for B and BB we will add. So what we can do here, before, so we can, this will be the start we will say, and this will be A, and this here we will make one more state for B, then one more for B, and then this will be, after this there will be one final state. Okay, so this will be the final state. So this one will be the final state and this will be non-final. So like this. And if you want after A one more null transition you can add, or between this B and B one null transition you can add. So that is optional. So for this also the same way, first we'll construct for A plus B, then A plus B star, and then we will add A before A plus B star, and after A plus B star we will add BB. So this is how we can construct any null NFA from a given regular expression. So hope the concept is clear to you. Thank you for watching.